Hi everyone, it's me, Carolyn, and welcome to another video. We are going to be starting a new chapter in this video, chapter 9. Chapter 9 is a short chapter. We will be looking at how to find confidence intervals and what that really is. I will be doing it a couple of different ways. One, using, of course, the formula in my calculator and the tables, but I will also be using StatCrunch. StatCrunch does speed things up incredibly. And I find it very helpful to not have to do all the crunching of the numbers in the calculator, but we still need to know all of the pieces. So I'm going to start by going to our guided notes so that we can kind of understand the terminology, first of all, behind a confidence interval and what that all entails. So first of all, the first term that we see up here, we are in chapter 9, and we're going to be estimating the value of a parameter. Now, remembering parameter means a measurement taken on the entire population. Most of the time, we do not have access to the entire population. So what we will do is we'll use a point estimate. Which is going to be a value of a statistic. Now, remembering a statistic is a measurement that's done on a sample, and we're going to use that value then to estimate the value of our parameter. Some examples that make sense to us is using X bar, which is our sample mean, as the point estimate for mu, which is our population mean. We could also use P hat, which is our sample proportion, to be a point estimate for our population proportion. We can use, another example is S, which is our sample standard deviation, point estimate for sigma, which is our population standard deviation. Now, we will only be concentrating on these two. The techniques for doing this one are very similar, but we, again, in this course are just getting a touch or a taste of the different areas of statistics. Now, since these point estimates are based on just a single sample, it is very likely that we don't get the exact value for our parameter. So there's going to be some little, how good of a sample did we get? Did we get a good point estimate? That remains to be never known, to be honest. So we do set up something called a confidence interval for this parameter. So we're going to not just find a point, but we're going to find an interval, so a range for which we're going to be more confident that this range contains that actual value. So the level of confidence is going to be represented by the proportion of intervals that contain the parameters. So in other words, if I want to say 95% confident, that means if I did this method and I created 95 of these confidence intervals based on 95 different samples, or a bunch of different samples, 95% of those intervals would actually contain the true proportion. The level of confidence is going to be denoted by this 1 minus alpha. Now, to draw a little picture, most of the time we're going to be looking at, in this section, either a normal curve or a T-curve, both of them being somewhat bell-shaped, so forth. So we're going to be finding estimates here, nice intervals. So this alpha that we're talking about here is the area in those little tails. So alpha is the area in the tails. And we will see that alpha again in chapter 10 also. And so the interval we find will be some sort of interval here. The confidence interval will be centered around our point estimate. So either our X bar or our P hat. They will be of a form. It's going to be this point estimate, and we'll be adding and subtracting. So we're going to go from the center point estimate. We're going to go up and we're going to go down. a certain value, and that value that we go is going to be called our margin of error. So how far away are we going to allow ourselves to be? So we're just going to jump right in here and come up with our formulas and just kind of work with them. So to find the 1 minus alpha times 100%, so like 95% confidence interval or 90% confidence interval for our population proportion, the formula looks like this. So it's going to be this p hat plus or minus this z alpha over 2, and we're going to have that square root, and we'll have that p hat, that 1 minus p hat all over n. This stuff might look familiar to you, and it does come from directly from when we were in chapter 7 and 8, when we were standardizing something involving p hat. You know, we were asking questions about the probabilities, and we were standardizing something. So we could have solved those things, because if you remember, our formula was like p hat minus p all over square root equal to z. Okay, to kind of solve that, finding your z's, which are these guys here, we'd have one positive, one negative, plus or minus. We'd be multiplying by that square root. Now this square root had a p in it, but we don't know p. So we're going to be using that p hat that we'll have from our sample. And then moving this p over there and solving it, we come up with this kind of formula as an estimate for p based on that standardization process. Now this all works provided, of course, we can use our normal. So we do need to remember those two steps, that we do need to make sure that our sample size is smaller than 5% of the population. Again, that is to make sure that our individuals are independent from one another, and that our n times p times 1 minus p is bigger than or equal to 10, so that we do get that basically normal looking curve. And if those things can't work, we can create a confidence interval and be confident that our true proportion is within those two ranges. So let's go and do an example and kind of walk through it. And again, I'm going to do one, I'll be using the formulas and showing you how to do these on the table. Also going into StatCrunch and getting those values as well. So we take a poll and we find that 322 of 2302 adults aged 18 or older at least have one tattoo. And we're going to be constructing a 90% confidence interval. So this 90%, and then we're going to interpret our results. So first of all, just some things we're going to make sure that we can use our formula. So I'm just going to talk through the first stage. We only have 2302 adults aged 18 or older. There are lots and lots and lots and lots and lots of adults. So this is well below that 5% of the entire population of adults over 18. Okay. The other piece that we do want to show is that n times p hat, since we don't know p, we want to find that to be bigger than or equal to 10. So the first thing I'm going to need to know is what my p hat is. Now my p hat is that sample proportion, so my 322 out of my 2302. And if I go and take that to a decimal, I get that that is 0.13987, and there's more decimal digits out there, but that is just fine. Okay, if I stick this fraction in here just so I can be a little bit more accurate, my n, that's the sample size, is that 2302. My p hat is this 322 out of 2302. And then we're going to take 1 minus this fraction. Okay. And we're going to take that into our calculator. I did this a little earlier to save me a little bit of time. And I found that that was 276.959, which is bigger than or equal to 10. So I am okay to use the normal curve, which is important because without that, I'm kind of at a loss. So what a lot of statisticians do is they make sure to have a large enough sample so that they can follow through. All right, so now we are calculating a 90% confidence interval. So thinking about our normal curve, our Z, 90% means what we want is we're looking for these Z values here. Okay, so that this middle piece is 90%. Okay, so that means our alpha is going to be that area in the tail. Area in the tail. And you will have noticed, I'm going to throw the formula back up here again. This p hat, that's our point estimate. We have this alpha over 2. The reason we have alpha over 2 is because you may remember when we first looked at the normal curve, we had what this z.1 and z.05. That was always this little area above that. So here, if we have z alpha over 2, so alpha is going to be the area in the tails, which is 10%. So the alpha over 2 is 5%. So that means we're going to be looking for z.05, which, if you remember our definition for this symbol, it's the z value that sits up here, where this is 5%. Okay, so if this is 5%, this whole piece down here is 95%. So I'm going to be looking inside the table for 0.95. So 0.95. 4, 4, 8, 4, 5, 9, 5. So right here between these two. And it is smack dab between those two. So I'm going to use the middle of those, which is a 1.645. So that's my z.5 is 1.645. All right. And now we're kind of ready to put all of our pieces together and get those two values. So again, I'm going to write our formula down. So it's a p hat plus or minus z alpha over 2 square root p hat 1 minus p hat all over n. And again, this is just ugly. And in a minute, we'll be using StatCrunch, which will do it in a matter of seconds. Our p hat is at 322 over the 2302. And we'll be adding or subtracting. And again, feel free to use decimals. My z alpha over 2 is at z.05 that we found by using the table. And then we have a lot of pieces. So I'm going to put my p hat 22 over 2002. And again, if you want to use decimals, please do so. But our calculators do have fraction keys on them. Okay. And of course, since I'm going to use my calculator, I am going to do a little bit of cleanup here first. So the first thing I would do is actually do this 1 minus and get the fraction that is. And I get that this piece in here, so I'm just going to kind of rewrite this. 322 over 2302. That becomes 1980 over 2302. Okay, so the first thing I'm going to do is get this ugly value. So I'm going to start with the mess in there. And so I'm clearing my calculator here, and I'm going to take that square root, and in parentheses, I'm going to do this guy, and then I'm going to multiply it by this guy in parentheses and all these things. So I'm going to be putting some extra parentheses in here. So I will be putting a big parenthesis at the start. I'll put these two in here. So I'm going to put a parenthesis, this 322 divided by 2302, clear that, close that parenthesis, multiply by another one, this 1980 divided by the 2302. And then I'm going to divide that by the 2302, close the parenthesis for the big thing here, and I'm going to multiply that by, so I'm going to get that number, and I have like a 0.007 or so. I'm going to multiply it by this 1.645. So if you're doing this by hand, you should be adding or subtracting like a 0.01189. Okay. And I'm going to get the decimal again for this, which was my 0.1398. So if I add the two, so adding is going to lead to my 0.15, and I'll go to 2 decimals, 2. If I subtract, I get 0.128 if I go to 3 decimals. So if I want to think of this, I have a lower bound of 0.128 and an upper bound of 0.152. So I am 90% confident that the true proportion of adults 18 and older who have at least one tattoo is somewhere between 12.8% and 15.2%, or in decimal form, the 0.128 and the 0.152. Okay, I am going to go and show you how to do this in StatCrunch, so that we can do a little bit faster, and we'll see that we do get the same values. So I'm going to switch screens here. And I tried to switch screens here. Okay, new share. And I want to go to StatCrunch. Okay, so I'm in StatCrunch. Now, you don't really need to enter any data here, but if we did have the original data, we could put some of the data in here. But we're going to go to our stat button here. So again, if we're doing a confidence interval for proportions, we're going to go to stats, and we want to go down to this proportion stats. Since we are dealing with a single proportion, so a single p-hat, like looking at one population, we'll be using this one sample piece. And we don't have original data, so we're going to go with summary. Okay, so again, stats, proportion stats, one sample with summary. And we'll get this window here. Now, this is where we could put all of the information. So the number of successes, which was our 322, out of our 2302, make sure I read my numbers correctly. We're not doing a hypothesis test. That's coming in chapter 10, but we're doing a confidence interval. So again, I'm going to click the confidence interval button here. The level that I want, which is a 90%, and I'm just going to go with the default method. So we're doing a 90% confidence interval, and there's my pieces, and that's all I need. So now I'm going to just compute. Boom, that was fast. A lot faster than it took me to actually calculate it. So here's my sample proportion. That's at 0.1398. And like I said, there was more digits that came. This is that error that we had that we were adding and subtracting. Here is your lower limit, the 0.128, obviously with more decimals, and the upper limit. So a lot faster than using the formula, which is why I like this. But I also want to make sure you understand that it is centered around that sample proportion. So this is going to be the middle of that interval. This is our lower limit. This is our upper limit. This standard error is how much we added and subtracted to get those two pieces. And it is based on the normal curve. So in order to do this, we still have to do those checks, that NP 1 minus P, and in this case, NP hat 1 minus P hat, to make sure that we can do this. Okay, so again, we went to stats, proportion stats, one sample with summary. And then we just entered in the pieces. All right, I am going to go back to our guided notes and finish what we're talking about, because we do want to talk a little bit about some other things. So that kind of gives us an idea on how to find a confidence interval. But what I want to talk a little bit more about, well, a lot of times this piece here, first of all, it's called the margin of error. StatCrunch called it the standard error, different names. One question is, how could we make it smaller? So in other words, we had right now this 12.8% to 15.2%. That's, that is pretty small, but maybe I wanted to even bring it in smaller so that I have a smaller range and then I could be here. One way to do that, just kind of looking at this formula, because we can't really change P hat. So the only things we can change are the values of N or the values of Z. So if I want to make my interval, and looking at my picture, my interval smaller, I have to make this area bigger, which means I'm going to decrease the confidence level. Okay, because we're going to make this area small, going to this picture, we're making this area, we're bringing this in. Okay, so thinking of this was 90%, if I bring it in, we're going to have less percent. So we're going to be less confident of the value being in there. So we could decrease our confidence level. Not something we always want to do because we like, as statisticians, to be pretty darn confident. But another one that we have more control over is that N. Now we have to kind of remember how division works. So we want this to be smaller because we're trying to make it smaller. So dividing by something bigger. So if we either decrease the confidence level or increase the sample size. And if you think about it, if you increase the number of people you're talking to, you're probably going to be more confident that you have a great sample, which can bring that piece down. Okay, so just kind of remembering, if you want to decrease that interval, there's two ways to do it. We can become less confident, so decreasing our confidence level, or increasing the number of people that we survey. All right, sometimes you're specifying a certain confidence. Let's say I want to be 99% confidence, and I want to have a certain size interval. So if I can control those two, we basically can find the sample size that will make sure that that happens. And so how do we do that? Basically what we do is take this wonderful piece here, which is our error, our margin of error, that's called E, and we're going to solve it for N. So if I set this thing equal to E and solved it for N, using some algebra, and I'm not going to go through the algebra. If you're interested, feel free to email me. We get this formula. Okay, so N is equal to this P hat times our 1 minus P hat. The confidence level Z's divided by the error that we have, and we got to square that, which undid our square root. And this came from flipping and things like that. So just kind of a little bit of algebra that got there. Sometimes you'll see that we do have a p hat in there. So if we have a p hat, maybe from based on before, this formula works good. But a lot of times if we're starting a brand new situation, we don't have this piece. Mathematics saved us here again. Actually, a calculus did. And it turns out that if we kind of overestimate what this is, by just letting it be 0.25, that will overestimate the n we need, which is fine because we can always get more people possibly, depending on what we're looking at. So we're going to look at two examples, or one example, just two different ways. And we can see how just overestimating doesn't change the n a huge amount, but it does change it some. Okay, so we've got this television sports commentator, and he wants to estimate the proportion of Americans who follow professional football. And he wants this to be within 2 percentage points. So 2%, which is 0.02. Okay, so 2%. Have to remember that is 0.02 in decimal form. And we want to be 95% confident. All right. And so first of all, he's doing this now. And he's going to use, because we could find out what the professionals, but they went back and they did it in 2016, and they got an estimate for their population proportion to get 48%. So he's going to use that first to see how many people he needs to go out and survey. So we're going to use our little wonderful m. And so our p hat will be this 48%. And then we'll have that 1 minus 0.48. My z alpha over 2, we have to find that. So remembering, we're doing a 95% confidence. That's what the guy wanted. So that's 95% in here, which means there's 5% in both of these. So 5% in 2 tails, or 2.5% in 1. Okay, so if I look for z 0.025, it's just the area up here, means we're going to use our table here, and we're looking for 5.975. So 0.97744. There it is. 0.975, and it's 1.96. It's 1.96. Kind of nice that it was right there for us. Okay, so that's going to be my z alpha over 2, 1.96. The error, E stands for the error. That's how accurate he wanted to be. He wanted to be 2% accurate, so 0.02, and we're going to square this. Just this piece gets squared. So our 0.48, and I'm going to do that little bit of subtraction, that's 0.52. And then I'm going to let my calculator all the work. Okay, and so then we will get a value going to my calculator, doing all the math. This number turns out to be 2397.15, and there's more digits. However, n stands for sample size. We cannot have partial people. To make sure that these things happen, we want to make sure that we have at least this number. So in order to have full people, we have to go larger. If I went to that, I wouldn't quite get what I wanted. I wouldn't quite get that 2%, or I wouldn't quite get the 95% confidence. So I want to go rounding up. That 2398 is how many people I'd want to go get. Okay. If you didn't have this 48%, or we didn't have any number to kind of go with, that's when we use this second formula. So we'll have that 0.25 Again, it's that Z alpha over 2 based on the 95%, still going to be my 1.96. We still want to be within 2%. So the only thing that changed was this piece up front. If I go and calculate this number and round to the nearest whole, rounding up completely, we get 2401. Notice there's not a lot of difference. This is the one that will be there, basically the maximum that we would need to get whatever confidence and error we needed. So knowing these two, the 0.25 will give you the maximum, that minimum kind of number. Okay, so this kind of gives us a start on confidence intervals. We did only do one example, but again, StatCrunch does such a beautiful job. I kind of explained where the thing comes from, and I hope that you guys can use StatCrunch. Here's my thing here. I just spaced out. I lost it. Not sure what just happened. You're connected. Well, I'm back. Hopefully I'm still recording. I'm not sure if I am. I'm still recording, so I'm not sure what just happened. Hopefully it didn't, my whole thing isn't screwed up. I'll have to watch and find out. But I hope that this makes sense, a little bit of a start to our confidence intervals. And I will see you in the next video in which we look at confidence intervals for the population averages. So I'll see you in the next video.